Hi, Algebra students. I'm super excited to welcome you to the Lesson 29 Project 6 recording. This is the very last one, so congratulations. You've made it a long way in this course. All right, we are still dealing with Erica, the innocent witness who was in the town of Soundford as a witness protection program participant. She was doing research on her new hometown, and she found the scatter plot that related pollen count to the number of noise complaints. So we're going to continue working with this. The first question here is the correlation of the given plot is calculated, the correlation coefficient of the given plot is calculated as 0.76. So, and then we want to know, is it a positive or negative correlation, and is it strong or is it weak? So the closer a correlation is to 1, the stronger it's going to be, and as we can see, it's a positive correlation. So this line of fit actually matches pretty well to the scatter plots and the direction that they're going. So we're going to call this a strong positive correlation. So first one done. Strong positive correlation. Okay, next one. The question, somehow I didn't have the question. Just give me a moment and I will come up with that question. The question for number 2 is which statement is supported by the data in the plot? Okay, so let's start at the bottom and go up. When the high pollen count makes people more likely to call the police. Well, let's see. As pollen count increases, the number of complaints do seem to increase. So but we need to determine something exact. So I'm not sure. That could be it. Let's look at the rest of them. The high pollen count makes people more likely to call the police. Interesting. The number of noise complaints makes the pollen count go up. Well, remember that the pollen count is our dependent variable, not our independent variable. So the noise complaints seem to be dependent on the pollen count. Okay, so that next one that I read will not work. Pollen in the air makes people play their music louder. Okay, well, we don't have any indication of that. That's not on the graph at all. All we have is noise complaints, okay? That's just not a piece of data that we are given. It seems like maybe that's a possibility because more people are complaining, but maybe they're just irritated. Their ear, nose, and throat are irritated, and so it seems like the music's louder. Okay, when there is more pollen in the air, there are more noise complaints. Okay, so as there's more pollen, there are more noise complaints. Okay, so the number of noise complaints seems to be dependent on the pollen count. So what is the difference between the first one and the fourth one here? The difference, when there is more pollen in the air, there are more noise complaints. That is shown by the graph. That's just a truth that is shown by the graph. Okay? The high pollen count makes people more likely to call the police. Well, we don't know if it's the high pollen count. We don't know if the high pollen count makes people more likely to play their music. We don't know if the high pollen count makes people's nose and ears irritated and then they call the police. So while there does seem to be a relationship between the high pollen count and calling the police, we don't necessarily know that the high pollen count makes people more likely to call the police. We just know that when there's more pollen in the air, they get more noise complaints. So it's the one that I've marked here. Okay, these are kind of hard. They can be a little bit tricky. I mean, it really seems like this one could be an answer, but really this is the only truthful relationship that we can definitely see on the graph. Okay, and so then the last, or not last one, the third question, let's see. So basically what we were getting at is correlation versus causation. So let me erase this and we'll go ahead and I think I have room to type down here. Okay, so we can describe individual reasons for each statement, or we can just say what the unsupported answers have in common. So basically, what I think would be the right thing to say here is that the unsupported statements are statements of causation rather than correlation. The supported statement was a correlation, and the unsupported statements were causation. So does that make sense? All three of these were identifying a potential cause, and this is acknowledging a correlation. The correlation is shown on the graph. The causation is kind of what you might derive from that, but you can't necessarily prove it based on the graph. Okay? And last but not least, the function for the line of best fit, as we determined previously, is f of x equals 1/4 x plus 3. Explain what the slope of the line and the y-intercept represent in the context of this problem. Okay, so the y-intercept is at 0 and 3. So what they're saying here is that even when the pollen count is 0, they get an average of 3 complaints. So I'm going to go ahead and type that in here. So y-intercept indicates that even when the pollen count is 0, they can expect 3 noise complaints. The slope indicates that for each increase of 4 in the pollen count, they can expect 1 additional noise complaint. Okay, that is officially it. We have made it through all of the projects in this course, and you should be finishing this course soon. Please remember that you can use the course and any notes that you've taken, any resources that you have, other than just outright getting the answer, on your final exam. So that's always something that I want to remind students, and I hope you do great, and I appreciate you taking the time to listen to this and all the other recordings. I hope you've had a great class, and I look forward to seeing you in Algebra 1B. Thank you.